Beyond the warm orbit of our sun, beyond the gas giants and the quiet Kuiper belt, lies a darkness so immense, so ancient, that even light travels for centuries to cross it. This is interstellar space, a vast frozen sea between stars, where no planet spins, no warmth flickers, no voice echoes. From Earth, we look out across this distance with instruments and wonder, grounded by the comforting rhythm of our own celestial family. Mars glowing rust red, Jupiter swirling with storms. Yet beyond him lies a silence untouched by orbit or origin, a realm not meant for us. And yet, from time to time, something crosses into view. For millennia, humanity has watched the skies with a blend of awe and certainty. Mars, with its pale red shimmer, inspired tales of war and dreams of life. Jupiter, massive and watchful, has long stirred both myth and mathematics. These planets, steady, returning, familiar, became companions in our stories and subjects of our science. We have mapped their paths, photographed their moons, and sent machines to orbit the storms. In them, we found a cosmic neighborhood, knowable, reachable, even nameable. And so, for most of our history, space meant what we could see, and what we could imagine just beyond it. The unknown was distant, but the known was enough, at least until the unknown came closer. But beyond the planets, beyond even the scattered ice of the Kuiper belt, lies a realm untouched by warmth or orbit. Interstellar space, a place without suns to light the way, without gravity wells to hold motion in rhythm, without a shielding embrace of a planetary system. Here, dust floats for eons, light dims across distance, and the silence is unbroken by any natural sound. Few objects dare cross this boundary. Almost nothing does so on its own. Even the Voyager probes, small silent emissaries launched decades ago, took over 40 years to reach that border, and now drift alone through the dark, whispering their telemetry into emptiness. It is a region so vast that stars are mere glints across light years, and so desolate that crossing it for anything not born there is an act of rare cosmic trajectory. In 2017, astronomers detected something unexpected, a fast-moving object slicing through the inner solar system on a path that no comet or asteroid had ever taken. It was too fast to be bound by the sun, too silent to release a tail, and too strangely shaped to match any known pattern. It tumbled as it traveled, elongated like a shard of cosmic metal. They named it Oumuamua, a word from Hawaiian meaning scout. No one knew what it was, only that it wasn't from here. Then, in 2019, came 2I/Borisov, colder, more traditional in form, with a bright coma and a tail of gas. Unmistakably a comet, but moving too fast, too straight. It too had come from beyond. With these two arrivals, the map of our solar comfort zone changed. The borders weren't walls, they were doorways, and something had stepped through. For the first time, the void had spoken, and we listened. After Borisov, the sky fell quiet once more. No new visitors came. The planets returned to their patient loops, comets traced familiar arcs, and telescopes turned back to stars we already knew. But beneath the silence, something lingered. A sense that the door had not closed, that the void might speak again. And out there, beyond light, beyond time, something could already be on its way. On the quiet night of July 1st, 2025, high in the Atacama Desert of Chile, one of Atlas's telescopes caught sight of something new. The ATLAS system, short for Asteroid Terrestrial Impact Last Alert System, is a network of 4 wide-field telescopes positioned across Chile, South Africa, and Hawaii. Every clear night, they scan the skies for anything that moves, capturing over 800 images as they search for asteroids, comets, and other transient wanderers. Most of what they find is expected, catalogued, familiar, but this one was different. It appeared as a faint dot, quiet, steady, and fast, just a few pixels wide. Its initial designation was A11PL3Z, a name as forgettable as its appearance. Yet as data came in from other observatories, something curious emerged. The object wasn't curving like an asteroid in orbit. It wasn't looping gently under the sun's pull. Instead, it was plunging inward on a steep, hyperbolic path. Follow-up measurements from both ATLAS and the Zwicky Transient Facility confirmed it. This object wasn't from here. Within days, it was reassigned by the Minor Planet Center. The new name carried weight, C2025N1, with a special prefix 3I, the third known interstellar object, and because it was first spotted by ATLAS, the network that watches while most of us sleep, it was given one more name, 3I/ATLAS. There was no fanfare, no flash in the sky, just a faint light on a digital image, and a quiet change in the story we tell about what drifts between the stars. Objects like this do not arrive often. In all of recorded human history, we have confirmed only 2 before it. Oumuamua in 2017 and Borisov in 2019. And now, this third, 3I/ATLAS. Each one arrived silently, unexpectedly, without pattern or warning. Their rarity speaks not only to the vastness of space, but to the precision required to glimpse them as they pass. 3I/ATLAS revealed itself not through spectacle, but through subtlety. A motion just beyond expectation, a brightness that lingered longer than it should, a trajectory that whispered of foreign origins. It does not loop back. It does not belong to the sun. It is, by every measure, a visitor. And unlike anything we have built, it comes from another star system, perhaps ejected by ancient chaos, or sent by forces unknown. Could this traveler carry secrets from beyond our stars, or something more? We cannot say, not yet. But its presence alone changes the silence, and the sky feels different now. This is only the beginning. 3I/ATLAS has just entered our view, a quiet light from a distant system, now traced by our instruments, named by our hands, and watched by our eyes. Its journey is far from over. In the days ahead, it will draw nearer, change, reveal its structure, its chemistry, its origins, or perhaps remain elusive. What it carries, in ice, in dust, in motion, may speak volumes about places we can never visit and events we will never witness. And so we follow, not with urgency, but with quiet attention. A story has begun, written in the arc of a visitor from the stars. Where it leads, we cannot yet know. Not every visitor knocks. Some simply pass by, leaving only questions behind. In the quiet dark of every night, our instruments gaze upward, patient, unblinking, vigilant. From a small world adrift in a vast, indifferent cosmos, we have chosen to watch. Not with fear, but with purpose. Though fragile, we've become quiet sentinels, eyes open not only for danger, but for wonder. We scan the heavens not to master them, but to understand our place within them. And sometimes, in that watchfulness, something extraordinary appears. Among these quiet sentinels, few are as diligent as the ATLAS system, the Asteroid Terrestrial Impact Last Alert System. Developed with the mission of detecting small asteroids before they strike Earth, Atlas now plays a larger role, watching the sky for anything that moves, anything that changes. Funded by NASA and operated by the University of Hawaii, this global network of robotic telescopes works tirelessly, night after night, beneath some of the clearest skies on Earth. Atlas operates from 4 sites across 3 continents. 2 telescopes rise from the volcanic slopes of Mauna Loa and Haleakala in Hawaii. Another peers upward from Sutherland, South Africa, a high, dry plateau long favored by astronomers. The 4th scans the southern sky from Rio Hurtado in Chile, nestled in the Atacama region's high desert silence. Each telescope takes up to 800 images every night, scanning wide swaths of sky covering the entire visible dome multiple times per shift. Together, these instruments do more than capture starlight. They record movement, they notice absences, they preserve the subtle drift of time across the heavens, and in their constancy, in their watchfulness, they catch what the human eye would miss. They remind us that vigilance, even in silence, matters. Each night, Atlas watches the sky alive with motion. Thousands of objects drift across its field of view. Near-Earth asteroids, tumbling rocks from the asteroid belt, distant comets making slow returns, and the steady blink of human-made satellites tracing ordered arcs. This is the traffic of the cosmos, familiar and mapped. Most of it holds no danger, no surprise. It follows patterns, curves through gravity's grasp, obeys the quiet laws of orbital dance. Yet among this vast choreography, something unexpected can move. Hidden in the flow, faint and fleeting, a visitor from far beyond may slip past. Most are never seen, not because they are invisible, but because we are not always watching closely enough. It takes persistence, precision, patience. Most movements are expected, but some are whispers from the unknown. On the night of July 1st, 2025, the Atlas Observatory at Rio Hurtado in Chile registered another moving point of light, one among thousands. It appeared as a faint signal in the digital field, barely perceptible, near magnitude 19, distant and dim. Its first designation was typical of its kind, A11PL3Z, a temporary code, one that, under most circumstances, would fade into data archives with little fanfare. But something about its motion was strange. Like many others, it shifted slightly across successive images, yet its path didn't curve as expected. It didn't arc gently like a body bound to the sun. Instead, it traced a straighter line, subtle but different, unanchored. It looked like so many other dots, dim, detached, and quiet, but this one didn't seem to belong. At first, there was no urgency, no flare, no alarm, only curiosity. Still, in the discipline of nightly sky surveys, curiosity can be powerful. It can turn anonymous data into discovery. This small object, at the edge of our awareness, had appeared exactly where few would think to notice. But it had been seen. And that, in the cold clarity of space, is how stories begin. Once the object was noticed, astronomers turned to a powerful tool, recovery. The process is simple in concept, searching through archived images taken before the object was officially detected to see if it had appeared unnoticed, and often it has. Indeed, the faint traveler had already crossed our skies. The Zwicky Transient Facility in California had captured it as early as June 14th. So had the other Atlas stations. Frame by frame, tucked within old data, the object left a breadcrumb trail, a record of its slow, steady approach. At the time, It was just another background flicker. But now, connected through hindsight, it became a path. Each recovered image narrowed the uncertainty. With every additional sighting, astronomers refined its orbit. They measured not just where it was, but where it had been and where it was going. What had once been a stray dot now moved with meaning. There is a quiet triumph in this kind of work, in patient attention, in the knowledge that something could be hidden in plain sight until someone thinks to look again. With a growing trail of observations, the object's trajectory was now ready for official analysis. That task fell to the Minor Planet Center, or MPC, based in Cambridge, Massachusetts. For decades, this quiet institution has served as the nerve center for cataloging asteroids, comets, and other small bodies that drift through our solar system. Every motion, every orbit, every anomaly is measured, checked, confirmed there. As data flowed in, the conclusion emerged. This was no ordinary orbit. It wasn't elliptical or even parabolic. It was hyperbolic, steep, fast, and open-ended. The object was moving too quickly on a trajectory too sharp to be held by the sun's gravity. It had not come from within. It was passing through, a visitor from beyond. With that confirmation came a new name, C2025 N1ATLAS. The designation held meaning. C for comet, its activity confirmed. 2025 N1 for its place in the calendar, the first comet reported in the second half of July, and Atlas for the survey that had found it. But one more name soon followed. Quieter, more momentous. 3I/ATLAS, the third interstellar object ever recorded by humankind. A traveler from another system, another star. From Cambridge to Chile, the path was now clear. The sky had revealed another messenger. As telescopes continued to track the object, a delicate feature emerged. A faint halo, just visible against the background stars. It was a coma, a thin glowing cloud of gas and dust, released as ancient ices warmed and turned to vapor. This subtle glow confirmed what the orbit had only hinted. The object was not just a cold rock drifting between the stars. It was alive in its own way, active, changing, responding. The sun, still far away, had already begun to stir it. From across billions of kilometers, its warmth reached out, and something frozen for eons began to melt, began to move. Its heart, frozen for eons, begins to breathe. From another star system, perhaps long gone, perhaps still burning, this small body had crossed light years untouched. And yet, here, under our star's soft influence, it bloomed. However faintly, it bloomed. Space is not silent, nor still. It is a sea of motion, invisible, immense, always flowing. Every object that drifts through it follows a path carved by gravity, shaped by stars, tugged by planets, curved by time. Most of these paths form loops, closed orbits, comets and asteroids that swing near the sun, then return to the dark, only to visit again someday. But not all paths return. Some cut through the solar system only once, drawn in from beyond, destined never to circle back. These are the open trajectories, the paths of true interstellar travelers. Among the many ways to trace such paths, orbital eccentricity offers a quiet key. On this scale, a value of 0 marks a perfect circle. Less than 1, and the shape is elliptical, typical of planets and comets that stay bound to our sun. But more than 1 means something different. A hyperbola, a line that does not close, a motion that cannot return. 3I/ATLAS moves on such a path, with an eccentricity near 6. It is not just barely unbound, it is radically free. No solar gravity could have held it. No planetary slingshot within our system could have made it so. It came in fast, and it will leave faster still. Imagine something flung with such force that no star can call it home, not even our own. This is the signature of interstellar travel, a sharp sweeping curve that cuts through the solar system only once. It is the calling card of an object born far away and merely passing through. Its speed, even before entering the inner solar system, was staggering, 58 kilometers per second. That is faster than any spacecraft built by human hands. Faster than Oumuamua, which moved at 26 kilometers per second. Faster than Borisov, which cut through at 32. Compared to the calm drift of most comets, 3I/ATLAS moves like a streak of urgency. Not wandering, but rushing. Its velocity is not the result of recent encounters or gravitational boosts from nearby planets. It is a velocity inherited from a place, a time, a force beyond our knowing. Through the vast quiet of space, where most things drift slowly for eons, this object moves like a whisper turned into a roar. It slices through orbits, through centuries of gravitational order, with speed unmatched by anything natural we have seen. It is the fastest interstellar object ever observed, a messenger in motion, a traveler that does not slow down because it was never meant to stay. Now it bends inward, briefly, toward our sun. Its steep trajectory curves toward a moment of closeness, perihelion. That moment will come on October 30th, 2025. At its nearest, 3I/ATLAS will pass just inside the orbit of Mars, at a distance of 1.4 astronomical units. Perihelion is the turning point, the closest approach to the sun, where solar radiation strikes with full intensity. For comets, this is often a moment of transformation. The frozen body awakens, ices begin to sublimate. A tail may emerge, streaming gently in the solar wind. For 3I/ATLAS, this fleeting visit marks the heart of its passage through our system. A moment of brightness, a curve of light, and then retreat. There will be no looping return, no long goodbye, just one close pass, then a sharp departure. A parabola becomes a slingshot. The visitor will not stay. And yet, even at its closest, it will not come near us. Earth remains far off the comet's track. Its nearest approach will be about 1.6 astronomical units, more than 240 million kilometers away. There is no risk, no possibility of impact, no disruption to our skies. It will glide past silently, out beyond the orbit of Mars, a faint object in deep space. And still, we watch. Because not everything must threaten to be worthy of attention. Sometimes, a thing captures us by what it represents, not what it endangers. It doesn't threaten us, but it commands our attention. Its journey cuts across the grain of the solar system, while the planets orbit in a shared direction, spinning like dancers in a slow, elegant waltz. 3I/ATLAS moves the other way, retrograde, against the flow. It is an interloper, not just in origin, but in motion. Its path slices through the plane of planetary order, tilted and independent. It follows no rule but its own. And it will not stay. There is no elliptical loop, no stable circuit around the sun. Its visit is brief, one steep turn near perihelion, then outward again, forever. It comes once and only once. In that short arc, it reveals its nature, not just by where it came from, but by how it moves. Its time here is brief and final. That brevity is part of the excitement. For astronomers, 3I/ATLAS offers something they've never had before: time. Unlike Oumuamua, which was discovered after it had already swung past the sun and was racing away, this object is approaching, still inbound, still changing. Its high speed confirms its status as interstellar, not just suspected, but unmistakable. Its steep trajectory offers clean observational angles. Its motion across the sky unfolds predictably but swiftly, allowing precise measurements of light, spectra, and structure. Each shift in brightness, each curve in its arc, each moment it spends within range of our instruments is an opportunity. This is more than a comet. It is a benchmark, a new data point in the growing story of objects from other stars. A visitor that challenges old models, tests new theories, and quietly rewrites the margins of our astronomical textbooks. What forces propelled this comet so swiftly across the cosmic dark? Was it cast outward by a giant planet in some forgotten system? Nudged loose by the tidal pull of a passing star? Or born from a cataclysm older than Earth itself? We may never trace its origin. No map reaches that far. No telescope sees backward through billions of years. But its path, sharp, swift, undeniable, is here, written across our sky. For now, that is enough to witness its motion, to measure its light, to wonder. In the deepest hours of the night, the stars seem eternal. Fixed points of light, unmoving across the centuries. We know their names. We chart their constellations. But every so often, something changes. A new light appears, faint, slow, and drifting. It is not a star, not a planet. It does not belong to any chart. It moves, softly, steadily, almost imperceptibly. A glow that was not there before begins to trace its way through the sky. Not brilliant, not dramatic, but undeniable. Its brightness, a beacon from distant worlds, glowing softly in our skies. 3I/Atlas is no small wanderer. Early estimates suggest its nucleus spans nearly 10 kilometers in diameter. A colossal body of rock, ice, and ancient dust drifting across our solar system. To place that in perspective, Oumuamua, the first known interstellar object, was a strange, elongated shard only about 400 meters long. Borisov, the second, resembled a more typical comet, spherical, active, and roughly 1 to 2 kilometers wide. But this newcomer is something else entirely. In volume, 3I/ATLAS dwarfs them both. It could be more than 10,000 times the mass of Oumuamua and several dozen times more massive than Borisov. It is the largest interstellar object humanity has ever observed, and perhaps the most massive to ever pass through our planetary neighborhood. It does not streak like a meteor. It does not roar like a spacecraft. It simply drifts, vast and silent, untouched by any star for millennia. A mountain from another star, drifting through our skies. Why does it matter that this object is so large? Because in astronomy, size is more than scale, it's opportunity. A larger surface means more area to observe sublimation, gas release, and the subtle dance of light off its coma. A bigger body better preserves the ancient chemistry of its birth, volatile ices and dust grains that may have remained unchanged since before our sun existed. And crucially, a larger interstellar visitor remains visible for longer. Its brightness holds steady across great distances. Its mass resists rapid disintegration. Its presence can be tracked with more confidence, giving astronomers time, not just a glimpse, but to study. With Oumuamua, we were too late. With Borisov, we had only a window. But with 3I/ATLAS, we may follow the journey from its first glimmer to its final fading arc. Despite its interstellar speed, 3I/ATLAS turns with quiet patience. Observations suggest a rotation period of roughly 29 hours, nearly 1 Earth day. It spins not in haste, but in rhythm. A slow revolution that unfolds with the measured grace of a moon drifting across the night. Astronomers chart its brightness over time, a light curve, rising and falling as different regions of its surface turn to face us. But this curve is flat, smooth, with only the slightest change. A mere 0.2 magnitudes of variation. That small fluctuation tells a quiet story. There are no jagged cliffs, no tumbling motions, no chaotic surfaces flashing in and out of view. Instead, 3I/ATLAS may be nearly spherical, a gently rounded world, its features blended and balanced across its form. It suggests composure, not violence. A traveler formed not from shattered fragments, but from the slow, ancient settling of matter in a distant system. It turns gently, steadily, like a world asleep. At first glance, a magnitude of 17.7 to 17.8 doesn't seem like much. To the naked eye, it is invisible, far too faint for any unaided gaze. But to those who know how to look, it is bright, startlingly so. Among interstellar visitors, it shines the most. Brighter than Oumuamua, brighter even than Borisov. In the language of astronomers, this is a beacon, not of fire or noise, but of consistency. It sits in the O-band, stable, reliable, and detectable by small telescopes the world over. For observatories, it is an easy target. For skilled amateurs, it is within reach. A ghost drifting just beyond vision, yet waiting to be caught in CCD sensors and long exposures. Its brightness does not dazzle. It does not demand attention. But in a sky full of familiar patterns, its steady presence speaks clearly. It says, I am here. I came from far, and I can be seen. As it nears the warmth of our star, 3I/ATLAS begins to change. No longer just a point of light, it grows a halo, a faint, diffuse cloud that surrounds its icy core. This is its coma, a blend of dust and gas, released as ancient ices sublimate under the sun's gentle heat. To most eyes, the change is subtle, but through instruments, it becomes unmistakable. This is not a lifeless rock drifting through space. It is a comet, active, reactive, transforming as it travels. Behind it, barely visible, trails a short tail, just 3 arcseconds in length. In deep exposures, it appears like a whisper, a shimmer that can vanish into the surrounding glow. Not grand, not sweeping, but present. A trace of motion, a sign of response. These traits mark it clearly. This object, born among other stars, carries more than mass and momentum. It carries history, chemistry, and the ability to change. Even after untold years between stars, it still responds to sunlight. Though 3I/ATLAS travels alone, its path is far from unseen. From observatories on remote mountain peaks to backyard telescopes under suburban skies, eyes around the world have turned upward and shared what they see. Much of this activity flows through the astronomer's telegram, a quiet digital bulletin board where professionals and amateurs alike report their findings. There, early images appeared within days of discovery, notes on brightness, observations on rotation, gentle speculation, cautious excitement, and above all, shared attention. Some posted sketches, others contributed photometric curves. A few captured time-lapse sequences, small animations showing the visitor drifting against the background stars. Each piece, no matter how small, added to the larger portrait. Each observer, in their own corner of the world, became part of a conversation that crossed borders and languages. Science, in its deepest form, is a shared language. And here, that language was spoken clearly, not with grand announcements, but with careful watching and quiet contribution. Among the visitors from the stars, 3I/ATLAS stands apart. It is vast, a mountain adrift in space. It is bright, the most luminous interstellar object we have seen. And it is seen not by one, but by many. A world watched by a world, through lenses both humble and advanced. Its motion is measured, its rotation steady, its glow quiet, yet unmistakable. A mountain of ice and dust glowing faintly, drifting through our skies. A reminder that the universe still sends us wonders when we are willing to watch. In the quiet of deep space, where sunlight barely reaches and shadows stretch for eternity, color still holds meaning. What does it mean when something glows red in the dark? Not a harsh, artificial red, but something muted, dusty, ancient. Through carefully filtered instruments, 3I/ATLAS reveals such a hue. Redder than the sun, redder than most asteroids. Its glow is soft yet persistent, a silent suggestion of age and origin. In space, color is never just beauty. It is chemistry. It is exposure. It is a record of time written in reflected light. And so we wonder, does this reddish glow speak of alien chemistry, formed in a distant cradle? Spectral analysis confirms the impression. The light from 3I/ATLAS is noticeably red, not just to the eye, but in measurable wavelengths. Its reflectance spectrum shows a steep slope toward longer, redder bands, placing it well beyond the sun's golden hues, and even darker than most known asteroids. It bears striking similarity to D-type asteroids, ancient carbon-rich bodies from the outer reaches of our solar system. These objects are dark, primitive, and thought to contain some of the oldest, least altered material in our celestial neighborhood. 3I/ATLAS also echoes Borisov, the interstellar visitor of 2019, whose deep red color hinted at a surface long exposed to the cosmic void. This isn't just a shade, it's a story. A surface burnished not by our star, but by silence and time. A world shaped far away and very long ago. The likely cause of this redness lies in organic-rich compounds coating its surface. Chief among them are tholins, complex molecules formed when ultraviolet radiation acts on simple carbon-bearing gases. These tholins, along with radiation-darkened hydrocarbons, tend to accumulate on objects that dwell in the cold outer reaches of star systems. There, far from stellar warmth, surfaces evolve slowly. Chemistry proceeds at a whispering pace, unhurried by heat or light. These conditions favor the preservation of primordial matter, rich carbon-based layers that record the quiet history of interstellar drift. This is the chemistry of distance, of silence, of time untouched. These organic compounds, though intriguing, are not evidence of life. They are not the product of biology, but rather its raw ingredients, prebiotic materials forged in the dark. Their presence on 3I/ATLAS tells us that the seeds of life, or at least the bricks from which it may be built, form naturally in the cold depths of space. If such molecules are common across the galaxy, on comets, on asteroids, on interstellar travelers, then perhaps the origins of life are not a rare event, but a frequent potential. No proof, but a quiet suggestion. A reminder that even in the most distant, silent places, the chemistry of life begins to stir. And this is no inert relic. 3I/ATLAS, faint though it may be, is active. Follow-up observations show the presence of a coma, a soft glowing halo of gas and dust that surrounds its nucleus. This is the hallmark of sublimation, where ancient ices buried beneath its crust begin to vaporize as the object approaches the sun. A short tail, only about 3 arcseconds long, hints at this gentle release, barely perceptible against the coma's glow. Yet even this quiet activity is profound. It means 3I/ATLAS carries volatiles, frozen compounds preserved over billions of years, now awakening in solar warmth. It is not just a rock. It is a dynamic, chemically rich traveler, a body that still responds, still changes, still breathes, even after its long exile between the stars. Beyond the poetry of color and chemistry lies a question of presence, of how often such visitors appear in our skies. For years, the ATLAS survey has scanned the heavens relentlessly, capturing thousands of transient objects, yet only one with the unmistakable fingerprint of interstellar origin. 3I/ATLAS. From this singular detection, scientists now estimate the density of interstellar objects to be roughly 0.001 per cubic astronomical unit. Rare, yes, but not vanishingly so. These travelers drift silently through the galaxy, unseen by most, occasional in appearance, but always possible. Their scarcity is not a void, but a rhythm, a quiet cadence across the vastness, a whisper from another star, heard only when we are listening. Perhaps this glow is the memory of another world, not a message, but a fingerprint left drifting across time. Not every journey leaves a blazing trail. Some pass quietly, etching only the faintest marks in the fabric of space. Since 2017, humanity has glimpsed just 3 such travelers, objects from beyond our solar system moving too swiftly to be bound by the sun. Each has spoken in its own way, through silence, through ice, through light. Together, they sketch a map of stories written in cosmic dust and starlit drift. Each visitor tells a cosmic tale. What story does 3I/ATLAS weave? Discovered in October 2017, Oumuamua was the first confirmed interstellar object, and it defied nearly every expectation. Unlike any known comet or asteroid, it showed no signs of outgassing, no coma, no tail. Just a dim, flickering point of light, traveling at breakneck speed through the inner solar system. Its shape, inferred from its rapidly varying brightness, appeared bizarrely elongated, perhaps 10 times longer than it was wide, like a tumbling cosmic needle. Even stranger was its motion. After its closest approach to the sun, Oumuamua accelerated slightly, in a way that couldn't be explained by gravity alone. But there was no visible jetting or release of gas, no sign of cometary thrust, just motion without a clear cause. This sparked a flurry of theories. Some suggested it was a shard from a tidally disrupted planet. Others, more provocatively, proposed it might be artificial, a defunct light sail drifting through space. Harvard's Avi Loeb championed this idea, arguing for a technology of non-natural origin. Still others speculated about exotic materials, perhaps a hydrogen iceberg vaporizing invisibly in the heat of the sun. But none of these theories have been confirmed. Oumuamua remains unresolved, a whisper of something truly alien in behavior, if not in origin, a question mark sailing across the sky. 2 years later, in August 2019, a new interstellar traveler entered our view, this time with less ambiguity. C 2019 Q4, Borisov, was unmistakably a comet. It sported a bright coma and a distinct tail, visible even through modest telescopes. At roughly 1 to 2 kilometers in diameter, Borisov was not only larger than Oumuamua, but also far more familiar in its appearance. What set Borisov apart, however, was its chemistry. Spectral analysis revealed it was rich in carbon monoxide, far richer than most comets in our solar system. This suggested it formed in an extremely cold environment where CO could freeze and remain stable. Some scientists propose that Borisov originated in a red dwarf system, where the outer regions might offer the kind of frigid birthplace needed to preserve such volatile compounds. While Borisov looked like a comet, it spoke of a different world. Its ices, its colors, its gases, all hinted at a formation history unlike anything in our own celestial backyard. Clearer than Oumuamua, yet still bearing the imprint of alien conditions, it marked another point on the growing map of interstellar origins. Now comes 3I/ATLAS, a visitor that seems to straddle the line between mystery and clarity. Like Borisov, it shows signs of cometary activity, a diffuse coma, a faint tail, subtle but unmistakable. But like Oumuamua, it holds compositional secrets that resist easy explanation. At roughly 10 kilometers in diameter, 3I Atlas dwarfs both of its predecessors, potentially holding over 10,000 times the mass of Oumuamua. Yet, despite its bulk, its activity is surprisingly modest. Borisov, a much smaller comet, displayed vigorous outgassing and a bright dramatic presence. 3I/ATLAS, by contrast, emits far less gas and dust. Its brightness comes more from its size than from its activity. Why would a larger comet appear so subdued? Scientists are still puzzling over this. Perhaps its ices lie buried beneath thick insulating layers, protected from solar heat. Or maybe its volatile content is simply lower, a product of where and how it formed. Another possibility, its long journey through space has left it hardened, crusted, resistant to change. In this quiet contrast, 3I/ATLAS whispers a different story, one that blurs the lines drawn by its interstellar siblings, a tale of mass without fury, of presence without spectacle. Where Borisov roared, Atlas murmurs. Its activity is real, measured, studied, confirmed. But it unfolds with restraint. No dramatic jets, no sweeping tail, just a steady glow and faint outgassing, a whisper of chemistry beneath an ancient crust. In this subtlety lies something profound, a reminder that the universe does not always shout. Sometimes it speaks in hushed tones, and still we listen. When scientists compare 3I/ATLAS with Borisov, another striking difference emerges, one of chemical memory. Borisov's composition showed a strikingly high carbon monoxide to water ratio, a signature pointing to its likely formation in an extremely cold, carbon-rich region, perhaps in the icy outskirts of a red dwarf system. In contrast, 3I/ATLAS appears to carry more primitive material, less processed, more stable, potentially older. These differences may be more than coincidence. Borisov may have formed in the frigid cradle of a small, cool star. 3I/ATLAS, with its subdued activity and preserved chemistry, may come from a system richer in metals, more mature and less extreme in temperature gradients. A place where time aged gently, not violently. Like fingerprints in frost, their chemistry remembers where they came from. Shape, too, holds its own quiet testimony. Oumuamua tumbled through space like a shard, elongated and uneven. Borisov, while more typical in form, likely bore the irregularity of most small icy bodies. But 3 I/ATLAS appears nearly spherical, a form suggestive of calm formation or long, slow aging in interstellar exile. Shape reflects origin, history, and fate. An elongated body may result from fragmentation or tidal disruption. Irregular forms may hint at collisions or violent pasts. A sphere suggests stability, endurance, time. In their forms, as in their paths, these travelers carry hints of where they began and what they've survived. Are these shapes stories, frozen in form? They come without names, without messages, without voices, just motion and light and silence. And yet, in their quiet presence, they reveal volumes, a curve of orbit, a chemical trace, a glint of reflection. These are the words they speak. Each visitor tells a cosmic tale. And 3I/ATLAS is still unfolding its own, quietly, as it passes through our sunlit window. Everything has a beginning, even a visitor from beyond the stars. Before it crossed into our skies, before it shimmered faintly in our telescopes, 3I/ATLAS was born in a place we will never see. A cradle not of our sun, but of some distant forgotten star. Hidden in a cold cloud of dust and gas, lit by pale light. Its chemistry tells us nothing here made it. Could it carry the chemistry of a carbon-rich star, or something stranger? The prevailing theory is simple, yet majestic in scale. 3I/ATLAS formed in the frigid outskirts of another solar system, in the icy debris field beyond its planets, much like our own Oort cloud. There it orbited for eons in darkness, stable and undisturbed. But space is not still. Over time, massive planets, stellar companions, or even passing stars may have nudged it, gradually shifting its path. One day, a final gravitational push flung it free, not into another orbit, but into the emptiness between stars. This exile was not violent. It was patient, a slow uncoupling from its sun. And so 3I/ATLAS began its solitary journey, one that may have lasted billions of years before it reached us. Before that ejection, though, it was born, not in fire, but in frost. Around a young star, a swirling disk of gas and dust flattened into rings. Near the center, heat, planets, chaos. But far out, silence and cold. There, icy bodies took shape, slow, quiet, and rich in ancient chemistry. These outer regions of a protostellar disk are time machines. They preserve the earliest materials, unheated, unaltered. Comets from such zones are not just debris. They are fossils. 3I/ATLAS, forged in such a place, is one of these. A frozen survivor. A message not from the star it orbited, but from the space that built it. How old is 3I/ATLAS? Based on thermal and dynamical models, its ices may be around 7 billion years old, formed long before our sun ignited. Unlike our comets, which have looped around the sun many times and evolved under its warmth, 3I/ATLAS has never been here before. Its surface has not been baked or reshaped by repeated solar heating. Its core is unprocessed, pristine, an untouched chemical archive. These are not just old ices, they are cosmic first drafts, frozen in place for nearly twice the age of Earth. With them, we peer not just into another system, but into another time. Chemistry offers more than colors and gases. It offers fingerprints. Spectroscopy of 3I/ATLAS reveals isotopic ratios that differ from what we find in our solar system. Its water may hold a different deuterium to hydrogen balance. Its carbon monoxide and other volatiles show distributions inconsistent with solar formation. These are subtle shifts, but they matter. Stars imprint their environment. The radiation, the dust, the elemental mix, all leave marks. And in the atoms of 3I/ATLAS, we see echoes of somewhere else. Not Earth, not here. Its atoms may carry the fingerprints of another sun. Across the galaxy, every stellar nursery crafts its ingredients slightly differently. A star rich in metals may build planets laced with sulfur or carbon. A poor star may yield icy bodies more fragile, more volatile. 3I/ATLAS is a product of its place. It may contain rare blends of elements, unusual ratios of carbon, nitrogen, sulfur that hint at a recipe unlike ours. Its chemistry is not alien in form, but alien in history. Some stars, known as carbon stars, have atmospheres where carbon outnumbers oxygen. These strange stars give rise to strange chemistry, carbon chains, exotic organics, soot-like dust. If 3I/ATLAS came from such a system, it could explain its rich red hue and abundance of complex carbon compounds. It would mean this object is not just interstellar, but formed in a radically different chemical environment. Such comets might be rare or simply hard to recognize. Until now. Somewhere, the star that formed 3I/ATLAS still burns, or perhaps it's long gone, collapsed, or cold. But its child survives. 3I/ATLAS drifts through our skies for only a moment, but carries memories of a sky we'll never see. In its silence, it carries a map, not of directions, but of memory, a frozen story from another sky. The galaxy is vast, billions of stars, endless planets, swirling dust and fire, and yet it is silent. No beacons, no new messages, just light, ancient and indifferent. Why is the night sky so quiet if life is not rare? Not all silence is emptiness. Sometimes it is caution, or a whisper too faint to hear. The galaxy's silence invites us to wonder. Among the more unsettling thought experiments in cosmic philosophy is the dark forest hypothesis, popularized by Liu Cixin's science fiction trilogy. It imagines the universe as a forest shrouded in night. Every civilization is a hunter. To reveal yourself is to invite destruction. In this forest, survival means silence. The wise do not shout. They camouflage. They listen. And if they must explore, they do so in secret. Perhaps by sending probes disguised as something else. Something harmless. Something like a comet. This isn't a scientific theory. It's a story about fear, caution, and the terrible weight of uncertainty. But as we peer into space and find no signals, no neighbors, its questions linger. Imagine a comet, dark and icy, drifting quietly through space. What if it's not entirely what it seems? If an ancient civilization wanted to observe the galaxy without being seen, what better disguise than something natural? A fragment of rock and ice, cold, silent, unremarkable. Such an object could drift unnoticed for millennia, waking only if needed. It would require no signal, no propulsion, no signature, just patience and purpose. It's a speculative idea, a story within a story. But like all good questions, it sharpens our curiosity. There is nothing obviously artificial about 3I/ATLAS, and yet its interstellar path, its calm brightness, its sheer size, all feel unusual. It arrived unannounced, just as the sky seems still. Unlike most comets, it came from outside everything we've ever known. A visitor from the void. Its presence stirs the imagination not because of what it shows, but because of what it suggests. So what does the science say? From the moment 3I/ATLAS was detected, astronomers watched closely. Its behavior, the gradual development of a coma, the subtle curve of a tail, matched the textbook profile of a comet heating under the sun. Spectrographs revealed only the expected molecules: water, carbon monoxide, faint traces of organics, no strange spikes, no unexpected lines. Its trajectory, plotted night after night, followed a pure gravitational path. No deflections, no anomalies. Radio telescopes listened, optical arrays scanned. Nothing spoke, nothing blinked. This is a natural object, one shaped by ice and dust, by silence and time. Its mystery is not one of malfunction or message, but of memory, of a distant beginning, not a hidden intention. Mystery, but not malfunction. Silence, but not signal. It is precisely its normalcy in such an extraordinary context that makes it beautiful. Science begins with questions, some practical, some poetic. Even the idea of disguised probes can be useful. It asks, what would stand out? What wouldn't? When we imagine the improbable, we refine our instruments to detect the implausible. We prepare ourselves to notice the truly unexpected. The boundary between wonder and rigor is not a wall, it's a bridge. Even if the comet is only a comet, it teaches us how to see. There are other ideas: self-replicating von Neumann probes, interstellar beacons hidden in plain sight, non-biological intelligences older than stars. These aren't answers, they're frameworks for asking better questions. And so far, nature continues to explain what we observe. The stars remain silent, and 3I/ATLAS says nothing, but still. It glows, it moves, it lingers. Its trajectory is a whisper, its chemistry a hint, its silence a canvas for wonder. We may never know if we are alone, but as long as the sky sends visitors, we are not without questions. In a galaxy that hides its voice, even a comet can become a question. Even in a universe ruled by gravity and inertia, there are moments where motion feels like choreography. 3I/Atlas did not stumble into our solar system. It arrived with elegance. From the dark beyond, it swept inward, curved gently past the sun, then traced a smooth arc outward again. No planets tugged at it. No moons pulled. It came and left, undisturbed. In that grace, we sense a question. Could such a path seem choreographed? The data is clear. 3I/ATLAS follows a hyperbolic orbit, a one-time arc through our solar system. It approached steeply, brushed past the sun at a respectful distance, and departed with equal poise. There were no close encounters with Jupiter, no nudges from Saturn, no loops or deviations. Its path is clean, precise, like a celestial needle threading through space. Astronomers watched it pass through our planetary neighborhood without so much as a ripple. Such precision is rare. Many comets are perturbed, tugged into eccentric paths, or shattered by tidal forces. But this one simply passed through. A cosmic guest that knew exactly where it was going. Most inbound comets don't fare so well. The gravitational fields of giant planets like Jupiter often capture or deflect them. Some plunge too close to the sun and disintegrate. Others linger, pulled into looping orbits that tie them to our star. But 3I/ATLAS avoided all of that. It threaded the solar system with improbable clarity, a trajectory so clean, it invites awe. Statistically, it's rare for a visitor to pass through without any significant interaction. Yet here it is, a line drawn through space, almost untouched. Despite its elegance, this path doesn't require intention. Physics allows for such things. 3I/ATLAS may have entered our solar system with just the right speed and angle to avoid planetary interference. Perhaps its journey through interstellar space included gravitational nudges that set it on this course. The cosmos is full of motion. Over billions of years, even rare alignments become inevitable. Among trillions of comets flung from untold star systems, some were always bound to pass cleanly through ours. In a universe of this scale, improbability is not impossibility. Sometimes coincidence is enough. The path of 3I/ATLAS, while graceful and rare, fits the rules of nature. In a universe of vast numbers, some paths will feel perfect. There is a part of the human mind that seeks meaning in patterns. When something moves with elegance, we instinctively search for purpose. A comet with such a smooth arc can feel like it was sent, like it was meant to be seen. But this is our pattern-making mind at work. Nature does not need an audience. Its grace is indifferent, and science teaches restraint. Beauty is not always design. Coincidence is not always code. Sometimes what we see is simply the result of motion, mass, and time. In a fictional sense, one might imagine, if a civilization wanted to send a quiet observer, what path would it take? One that avoids detection? One that threads the solar system without interference? One like 3I/ATLAS? This is not a claim. It's a metaphor, a soft lens through which to wonder. Because as fantastical as it seems, imagination sharpens perception. We ask better questions when we entertain unlikely ones, but always we return to the data. And here, the data tells a natural story. What is improbable is not impossible. In statistics, outliers are not anomalies. They are inevitabilities given enough time. Astronomers observe thousands of celestial bodies. Among them, one will eventually trace a path as clean and curious as this. 3I/ATLAS is that one. Not the first to visit, not the last to surprise, but a reminder that even within order, wonder persists. It came fast, moved quietly, left nothing but data and a question. The dance of 3I/ATLAS may be coincidence, but its grace is real. It passed just close enough for us to notice, far enough to stay mysterious. It was not loud, it did not linger, but in the stillness of its passing, we ask, is it chance or something more? Sometimes, even in solitude, we feel a presence, a gaze, a quiet awareness. In space, that feeling becomes a metaphor, not for fear, but for possibility. What if just once something looked this way, not to conquer, not to speak, but simply to observe? In the long quiet between stars, such a question becomes a whisper. Is anyone watching? The idea that 3I/ATLAS might be a watcher, not merely a wanderer, is not science. It is a story, a thought experiment. What if an interstellar comet was something more? A probe, disguised in ice, no signal, no sound, just motion, not a beacon, a lens, not a scout of conquest, a camera. It would pass through our solar system as if by chance. No interruption, no interaction, only observation. This is not a claim. It is a metaphor, a story to hold alongside the data. If it were a probe, what would it look for? Not grand structures, not flashing cities, just signals, patterns, changes in light and chemistry, perhaps a brief bloom of radio noise from one pale blue dot. It would collect, not interfere. Watch, not judge. A visitor that never lands, never speaks, never breaks the surface. A silent flyby. One glimpse, then gone. We would never know it watched us. It would leave no mark. But perhaps, in the quiet drift of 3I/ATLAS, some feel that idea stir. Yet all observations of 3I/ATLAS say otherwise. Its coma and tail react to sunlight as expected. The arc of its orbit traces a natural gravitational curve. No strange accelerations, no deviations. Its chemistry aligns with other comets, rich in water and carbon monoxide. In every wavelength, it is silent. No artificial pulses, no anomalies, no clues of a craft. Science sees a comet, familiar though from afar, mysterious only in age and origin. And that's enough. Still, the mind drifts, not because we distrust data, but because we are built to wonder. When something comes from beyond our star, we imagine. That is not weakness, it is how we prepare. A visitor from the dark calls to something ancient in us, a storyteller's instinct, not to explain the unknown, but to live with it. In the end, speculation must meet data, and here, data holds. Every observation of 3 I/ATLAS matches the expectations of a comet from another star. Its behavior is natural, its path explainable, its chemistry consistent. Science is not blind to wonder, but it demands evidence, not allure. So far, this object needs no mystery to be marvelous. Even if 3 I/ATLAS is just ice and dust, it reminds us others exist, other systems, other beginnings. It watches nothing. Yet in watching it, we remember how little we know, and that too is a kind of message. It sends no signal, it answers no questions, but it moves through our sky, softly glowing, briefly seen. Science sees a comet, but the heart sometimes sees more. A silent watcher, a distant echo, a fragment of another story passing quietly through ours. To see something strange in the sky is to feel the pull of curiosity. From ancient stargazers to Galileo's lens, we've always reached toward the unknown. Now, a traveler from another star brushes past our world. We track it with telescopes. We map its path. But deep down, we wish to get closer, to touch it. Touching this traveler, a chance to hear tales from another star. Scientists across the globe are focused on 3 I/ATLAS. Ground-based telescopes continue to gather data on its motion and brightness. But more powerful eyes are preparing. The Hubble Space Telescope aims to capture detailed images, while the James Webb Space Telescope, JWST, may soon collect its infrared signature. These instruments are time machines. They allow us to peel back layers of light and dust. With them, we can detect water, carbon monoxide, and other molecules locked in 3 I/ATLAS's ancient ices. We can compare its chemistry to the fingerprints of our own comets. Look for differences. Look for echoes of another sun. This is how we study something too distant to reach. We read its light. The opportunity won't last forever. After perihelion in late 2025, 3 I/ATLAS will be best placed for deep study. It will be bright enough for high contrast imaging and positioned well in the night sky for extended tracking. Every week that passes beyond that window makes data harder to collect. As it drifts farther into space, its light fades. Its secrets become harder to hear. Now is the moment. Astronomy, like all exploration, is a matter of timing. Spectroscopy turns light into language. By splitting 3 I/ATLAS's faint glow into colors, scientists uncover the molecules it carries. They can detect water, carbon monoxide, methane, ammonia, even subtle differences in isotopes, like deuterium in its water. These ratios help map its birthplace, revealing if it formed in a warm or cold region near a red dwarf or a sun-like star. It is a kind of cosmic forensics. No scalpel, no sample, but still a reading of a distant past written in photons. After Oumuamua's flyby in 2017, a team of engineers and astronomers imagined the impossible, launching a probe to chase it down. They called it Project Lyra. While it never launched, the idea lives on. Project Lyra became a blueprint for future missions. It outlined what it would take to intercept fast-moving inbound objects like 3I/Atlas. Rapid launch readiness, high-efficiency propulsion, and clever gravity assists. The challenges are immense. An interstellar object moves fast, and you only get one shot. Catching it requires not just speed, but precision planning years in advance. We weren't ready this time, but next time, maybe we will be. Why all the effort? Because a sample from beyond the solar system could change how we understand everything. In that material are clues to stellar evolution, planetary formation, even prebiotic chemistry. It might contain isotopes forged in long-dead stars, organic molecules untouched for billions of years. To hold a piece of another system in our hands, that is not science fiction. It is the next great chapter of planetary science. There may be thousands of interstellar objects passing silently through the galaxy, but very few come close enough to observe. Fewer still present such a pristine, active face. 3I/ATLAS is one of those few. Each encounter helps us test our theories. Each object carries its own cosmic history. Together, they may one day form a map of the galaxy's diversity. This is how science moves forward, not with easy questions, but with distant possibilities. It crossed a gulf of stars. It carries the memory of a place we may never see. We watch it through glass and data. We imagine what it holds. And maybe someday, when the engines are ready and the timing is right, we will reach. In its silence, it carries stories, and we're learning how to listen. The light is still there, but fainter. 3I/ATLAS, having looped around the sun, now begins its slow retreat into interstellar space. Its path is outbound, its brilliance waning. Like a traveler stepping into shadow, it leaves behind only a soft fading glow, not a disappearance, a departure. Now outbound at over 58 kilometers per second, 3I/ATLAS climbs away from the sun on a hyperbolic path. Its arc is steep and decisive. It will not return. No planet deflects it, no star captures it. It came in from the dark, and it leaves into the dark. Its future lies in the void between stars. Perhaps one day it will pass near another system, another observer. But for us, the window is closing. Through late 2025 and early 2026, astronomers will complete their final observations. The data stream will narrow, then end. Once bright and sensitive scopes, 3I/ATLAS will fade beyond reach. What remains will be petabytes of images, spectra, and light curves. And one more name in the growing list of interstellar travelers. This object confirmed the richness of the galaxy's debris. Its surface glowed red with complex organics. Its coma responded gently to solar heat. Its trajectory marked it as unbound, interstellar. Spectroscopy hinted at exotic isotopes. Its ices remained pristine, likely older than our solar system itself. No signs of artificiality, only the majesty of natural processes across light years. It brought no messages, but it offered insights into alien chemistry, planetary formation, and the ancient cold of protostellar clouds. We don't know where it came from. We can estimate regions, perhaps near a metal-rich, carbon-heavy star, but not a specific point. We don't know its inner structure, only its surface and outgassed vapors. We don't know how many collisions or ejections shaped its path. Its journey hides more than it reveals, and maybe that's fitting. 3I/ATLAS reinvigorated planetary science. It united observatories, inspired mission studies, and reminded us that space is not still. It showed that even from afar, we can read stories in light. One comet, one passage, hundreds of new questions. As 3I/ATLAS fades, the sky grows quiet again. But we are changed. We know such travelers exist. We know how to spot them. We will watch more closely now and wait. From the void it came, and to the void it returns. But not unnoticed, not unloved. We saw it, measured it, wondered at it. Its path was silent, its light brief. But it leaves us changed, not with certainty, but with perspective. It was only here for a moment, but that moment changed how we see the stars and how we listen to their silence. For every interstellar visitor we detect, how many slip past unnoticed? Space is vast, and our eyes are few. Even with all our telescopes, much of the sky remains dark between scans. Tiny wanderers, swift and silent, pass through without light or warning. It's a humbling thought. We only see the ones that happen to cross both the sky and our gaze. Countless travelers slipping through the cosmic night, unseen. Based on recent survey data, astronomers estimate that there is roughly one interstellar object for every 1,000 cubic astronomical units of space. That's 0.001 per cubic astronomical unit. This figure comes from years of careful tracking, especially by the ATLAS survey system, which scanned the sky night after night, accumulating a statistical sample. To visualize, imagine the space between Earth and the Sun. Now, cube that volume. In that space, on average, there's one interstellar object drifting slowly across the centuries. Rare, but not beyond reach. Most interstellar objects are small. They reflect very little sunlight. They move fast and enter from random directions. Many pass near the Sun or Earth unseen, hidden in daylight or beyond our detection threshold. Their windows of visibility are often brief, a few weeks, sometimes days. By the time they brighten enough to notice, they may already be leaving. We miss more than we see, but each detection sharpens our awareness. The ATLAS system scans the entire sky every night, searching for transient events, new comets, asteroids, supernovae. Its algorithms are tuned to catch faint, fast-moving objects. Sometimes, Atlas finds an interstellar object in real time. Other times, it discovers them in retrospect, spotting that they appeared in older data days or weeks earlier. 3I/ATLAS was one such case. Though officially recognized in late June 2025, images show it was visible as early as June 14th. Each success improves the system, and the next wanderer may be caught even earlier. The statistics are clear. Interstellar objects are uncommon, but not extraordinary. If current trends hold, we might detect one every few years, and with better instruments, the pace may increase. These aren't once-in-a-lifetime events. They're rare alignments of time, place, and readiness, and they're becoming more familiar. Space seems still, but it's not. Millions of objects drift, orbit, and spiral through the solar system. Most are local, our comets, our asteroids. But now, we know a few come from other suns. Even as we sleep, they pass overhead. Invisible, but real. The cosmos is not quiet. It's full of quiet motion. To witness one of these travelers is rare, not because they are impossible to find, but because seeing them requires timing, technology, and attention. It means being ready when the sky offers a visitor. They do not know they've been seen, but we remember. How many passed by before Galileo, before photography, before radar and CCDs? How many more will pass in the next 100 years? We won't catch them all, But each one we do is a message of motion, a signpost of what moves between the stars. The sky is full of messengers. We just need to know how to hear them. We often imagine our world at the center of things, but the sky says otherwise. When an object like 3I/ATLAS arrives, unbidden, unknown, it feels like a page turning in a story older than Earth itself. These are not local tales. They are galactic verses. Are we alone, or part of a larger cosmic tapestry, perhaps observed? 3I/ATLAS is the third known visitor from another star system. Like Oumuamua and Borisov, it offers more than just mystery. It offers connection. These aren't just rocks or ice. They are bridges, threads of material linking one system to another across unfathomable distance. Could they carry the building blocks of life, or the chemical fingerprints of alien cradles? Theories like panspermia suggest life might spread between worlds via such cosmic messengers. Others speak of galactic ecology, genealogy played out in dust, water, and time. We don't know which, if any, are true. But each visitor forces the question. These objects are more than curiosities. They are emissaries of distant origins, bridging stars not through intention, but through motion. They do not speak, they drift, and yet in that drifting, they cross borders few forces can. They are not machines, not messengers, not calls, but still, they carry stories because matter remembers. Perhaps it is not only gravity that guides such paths, but curiosity. We reach because we wonder. We build telescopes, run simulations, debate theories, because something in us yearns to understand. And maybe, if others exist, they do too. Maybe this desire to observe, to seek, to marvel is not uniquely human. Maybe it is cosmic. These objects shift the boundaries of what we believe is possible. They reveal that our solar system is not isolated, but porous. They suggest that interstellar travel, even in primitive form, is already happening. Not by intent, but by nature. We've learned to model how planets eject comets. We now consider the solar system's edges as fuzzy, overlapping zones. Each visitor alters those models. They don't just pass through our skies. They pass through our thinking. Think of the galaxy not as a void, but as a tapestry. Stars are nodes, planets are knots, and interstellar objects, threads that wander. They're not lost, just moving, briefly intersecting our path. And we, too, are a thread that has begun to watch. Could someone else be watching us? Not with cameras, not with probes, but with awareness? We don't know. There is no evidence. But a thought lingers. Perhaps others once saw an object like 3I/ATLAS pass their skies and wondered just as we do. We are not the center. We are a node in motion, a spark in the quiet. With each interstellar visitor, we are reminded of scale, of possibility, of participation. These travelers pass briefly through our skies, but they help us see where we truly are, adrift, aware, and still wondering. There it is, a dim glow retreating into the dark. 3I/ATLAS, once bright in our instruments, now fades with each passing day. It has rounded the sun and begun its long journey outward. It is no longer rising, it is leaving, and yet its presence lingers. As it fades into the void, it leaves us with wonder and peace. Now outbound at over 58 kilometers per second, 3I/ATLAS is climbing away from the sun on a hyperbolic path. There will be no return, no slow arc back to where it came. Its motion is steep and clean, a straight line grace through the solar system. It entered untouched, and it departs the same. The planetary plane shrinks behind it. The stars ahead offer only silence. It has passed through our reach, nudged by no planet, tethered to no star. A one-time crossing, a singular moment, and then distance. From December 2025 onward, 3I/ATLAS will once again become visible, no longer lost in solar glare. But it will be fainter now, and fading fast. For a time, large telescopes will still catch glimpses, a speck on the move, a ghostly blur on long exposures. And then, even that will slip away. Our last views will live in memory and in data. Though invisible to the eye, 3I/ATLAS can still be found. NASA's JPL Horizon system lets anyone track its position second by second. Just enter its name, and its coordinates will appear. It is still there, still real, still outbound. Even as it vanishes from our skies, observatories will quietly log its position. Line by line, it becomes part of the shared map. Its spectrum, trajectory, and coma will live on in archives. Scientists will analyze and reanalyze its data for years. It has joined the short list of known interstellar travelers. It may become the reference point for the next ones. Its name will echo in papers, in presentations, in dreams. Its light may fade, but its legacy will not. When 3I/OTLAS came, the sky seemed louder. Now it seems quieter, but it's not empty. It changed what we expect, what we notice. It trained our instruments and our imaginations. The quiet it leaves behind is a new kind of quiet, one that listens more carefully. We watched it pass, knowing it was not from here, knowing we would never see it again. It brought no message. It asked no questions. And yet, we answered. In observing it, we reflected on ourselves, our place, our role, our future. Some guests say nothing before leaving. Their visit is wordless, but meaningful. 3I/ATLAS will never know we saw it, but we will not forget. In the end, it passed through more than our sky. It passed through our thoughts, and quietly, it stayed.